Today we are going to start talking, guys, let's focus. Today we're going to add something to what we've been doing. So we've been working out integrals, but as a general infinite answer, right? So we have been giving, so we're going to do some application stuff later. So the application of indefinite integrals, which is what we've been doing, is just the graphs itself. But if we put limits on the graph, we can chop it off at certain points and find area and volume for a specific section. So what we need to do is change what we've been doing and make it finite. So we're going to make it definite. So we are going to start adding in boundaries, or what is called limits. So we're going to have an upper and a lower limit, or an upper bound, lower bound. All of that terminology works for the part of the graph we're interested in. So I'm going to give you a horrifying looking equation right now, but I'll show you how it works, and it's really nowhere near as scary as it's about to look. So we have the integral between A and B. Now we start with A at the bottom. B must be greater than A. Okay, so let me just write that down. So B is always, thank you, B is always greater than A. So the bigger number always goes at the top of this, okay? And then I'm going to have, sorry. Do I want to write it like that? Yeah, okay. I'm just going to stick to the way the book writes it for now. So, oh, I shouldn't have put a negative there, should I? Because that implies something different. The integral, the derivative of this with respect to dx is going to be the function itself limited by those things. And I'll show you exactly what this means in a second. So what this really means is we take the function with b plugged in and we subtract the function with a plugged in. And I'll show you what that looks like, because it's really nowhere near as ridiculous as it just looks. So I'm going to give you a very, well, it's maybe not the most simple thing in the world. So I want to, let me just move this up a little bit. So my example is find the integral of 3x minus 2 to the power of 8 with respect to dx, and then hence, that's not how you spell hence, find 8/10, find the integral of 3x minus 2 to the power of 8, and I'm going to give you limits for that. So I'm going to put the limits over here between 1 and 0. All right, so the only difference is that you get numbers over here now. So it's no longer an infinite integral, it is a defined integral. So first of all, we're just going to find the integral of this.
1 and 0.
Yeah, 1 and 0 are the two numbers. So, okay, right, so I'm going to have 3x minus 2 all to the power of 9 over what? Oh, sorry, actually, I have a new 3 times what? No, it's the new power. It's 3 times 9. So remember, I take the A and I multiply by the new power. Did I not do that? Oh, sorry. Sorry, my bad. We're adding something else. I just didn't write that bit down. Okay, so, right. You're right. Yeah, sorry, I haven't. Okay, what you do with this type of thing, if it's something squared, just expand it and do the integration like normal, okay? But if the power is really high, like an 8, you do not want to go through all of the annoyance of having to expand 8 brackets, okay? So this is essentially the reverse of the chain rule, right? So what we're doing is we're taking this differential, right? The difference of what we called u before, remember, we substituted that, so 3. So it's always just a, it's the number in front of x. Bring that down, multiply it by the new power, we're dividing by the new power, multiplying these, okay? So you just end up with, oh, actually, I'd rather write it underneath so I have more space. So I get 3x minus 2 all to the power of 9 over 27. Now, I want to find the actual value between 0 and 1. So I'm going to do it in blue just so we can see. The first thing I'm going to do is substitute in 1 for x. Then I'm going to substitute in 0 for x, because those are the two values that we want. So I'm going to take this at the end. So I've got 3 times 1 minus 2 to the power of 9 divided by 27 minus 3 times 0 minus 2 all to the power of 9 over 27. And given that I've done this earlier, this is 1 over 27 minus, not minus, plus 512 over 27, which is wonderfully 19.
Wow.
So all you're doing is doing the derivative, and then once you've got the thing that we normally get anyway, you plug in 1 and 0 for x. You put the bigger number first, and then you subtract the smaller number. Yeah. Okay, well, we're going to deal with that later. So we're going to do the application stuff later. For now, we just want to practice doing it. I am going to upload a video if you really want to see that right now, but I don't really want to overwhelm people with information. But it is about the area under a curve or the volume of a 3D shape as you revolve that curve around an axis. So again, I don't want to, if you have no idea what I'm talking about, don't worry about it, but it is applied to the area of a curvy space, whether it's 2D or 3D. That's what we're doing between the values of 1 and 0 on the x-axis, right? So we're limiting the graph. So I'm just going to draw a very quick example. Let's say that I had a graph that looked like that, and I went between 1 and 0. Actually, let's not say that that's 1. 1 and 0, what I'm finding is this area in here, right? So according to this, the area of this graph between 0 and 1 is 19 units. Okay, we'll talk about that more later. Yeah. You don't, because let me give you a reason for that. Right, so you don't need to add the c. That's a really good question. I'm just going to quickly show you why. If I have 3x squared plus, why did I write plus twice? Plus 5, and then let's say that that's my thing, right? So I do 1 squared plus 5 minus 0 squared plus 5. I'm adding 5 and then subtracting 5, so they disappear. So that's why the c is irrelevant, because when you take one thing and subtract the next thing, the constant will be the same, so it doesn't need to be there at all. Does that make sense? Okay. So let me just quickly give you that other thing I just did. So actually, let's just pick some new numbers. 5x plus 4 all to the power of 7. I want to find this integral with respect to dx. Okay, so what I'm going to do is I am going to add 1 to the power, and then remember we divide by the new power, but we also have to divide by the derivative of this, which is 5. Okay, so that's the only thing we're adding to this. So this is now 5x plus 4 to the power of 8 all over 40. Okay, so just add one thing. Instead of dividing by the new power, we divide by the new power and multiply it by the derivative of the brackets. Yes? Okay, good. So in that case, I am going to give you a very simple version of this, and I would like you to have a go at doing it. So, yeah? Those are the limits, right? Those two things that we're giving you are the limitations. We're not, that's exponential graphs you're talking about, right? So, and that's also infinite areas and series and stuff. So if I have 5 and 2, and I want you to find the integral of x squared with respect to dx, I want you to have a go at doing what I just did with this simple version of it. So you want to integrate, and then you also want to use these two numbers to give you the value. You should have some weird fraction. It's not going to be some nice round answer. You have what? No, you shouldn't. Maybe I typed it into the calculator incorrectly when I did it. Is this what you have? And you get a whole number answer?
Yeah.
I thought I typed it into the calculator. Maybe I typed it in wrong. Maybe I am wrong. Clearly. Let me do it again.
Did you use brackets?
5. Don't need any brackets. What do I need brackets for? Oops. Oh yeah, I got a whole number answer. I guess I did it wrong before.
Yes, that's what I got.
All right, good. All right, my bad. I don't know what I typed in before. Anyway, so we find the integral and then we just substitute in the x values, the big one minus the small one, and this is what we get. Okay? All right, let's look at a really complicated one. So we're going to do that exact process, but I'm going to make it weirder. Well, I'm very happy to give you a go at doing it. 2 plus root x squared. All right, you can have a go at doing that. See if you can follow the same process. What do you think you should do first? I would expand the brackets first. Okay, expand your brackets, then find your integral.
When you multiply powers, you just add them.
Correct.
That's good. Oh, wait, there's still pressure.
Yeah. Did I do that? What? Oh, it's a 1. Sorry. Yeah, I've written the wrong thing. Thank you. All right. Yeah. Big one minus the small one. Okay. This is it. The first thing you need to remember is that rule. Remember the reverse of the chain rule where we have to also divide by the derivative of the brackets. And then in the second exercise, you're doing actual definite integrals. So for the first exercise, you don't need to do definite integrals, just for the second.